Hello everyone, have you ever wondered how the universe began? Well, today we are going to learn about a Big Bang theory. Not this one. We are going to learn about the origin of universe. So during the 19th century, people believed that the sun, moon, star, even the human being, they never had a beginning. They have always been existed forever. But this was totally wrong. Each and everything has origin, so the universe also has an origin. How the universe was created, when the universe was created, these are the questions still present in the mind of many people. So, before exploring the Big Bang theory, let us consider its supporting evidence. So, there are four evidence of a Big Bang that prove the Big Bang theory. First is the expansion of universe. Second is the cosmic microwave background radiation. Third is the abundance of hydrogen and helium in the universe. And fourth is the age of the universe. The first evidence of a Big Bang, we get it from the expansion of universe. In the year 1920, the American astronomer named Edwin Hubble provided the first evidence that the universe was not static, rather it was expanding. He proved that there is a direct relationship between the speed of a distant galaxies and their distance from the Earth. Further they were from the Earth, faster they were moving away. In short, the galaxies are moving away from each other. Hubble come to know about the expansion of universe by calculating the distance of different galaxies and by observing their spectra. So whenever the source of light is moving, there is a change in the frequency of a wave due to the moment of the light source, and because of that there are two kinds of shift in the spectra of light. First is blue shift, second is the red shift. So the galaxies which are moving away from us will have their spectra shifted toward the red end of the spectrum, and the galaxies which are moving toward us will have their spectra shifted toward the blue end of the spectrum. So what Hubble found that most of the galaxies are red shifted rather than blue shifted. This eventually led us to the conclusion that the universe is expanding and galaxies are moving away from each other. To make it understand you very easily, I brought the spectra of a different object and the galaxies. So here you can see this is the spectra of a different galaxies and the nearby star. So you can see the first spectra represent the laboratory reference. Okay, it's ideal. So when you take the nearby star, you can see this black line is shifted more toward the red side of the spectrum. Okay, it means this star is moving away from us. And if you take the nearby galaxy, then you can see there is a little more shift in the spectra. It means this nearby galaxy is moving faster compared to the star. Okay, now next is the distance galaxy. You can see in the distance galaxy there is a big gap. There is a very big shift in the spectra. This black line is shifted more toward the red end of the spectrum. So it means till you can see till the red end of the spectrum. So it means that this distance galaxy is moving faster away from us compared to the nearby galaxy. And if you take a very distant galaxy, so you can see there is a very huge shift in this black line of the spectra compared to the rest of the object. Okay, the reason is why, because as per the Hubble's law, further the distance, there will more shift in the spectra, and faster the galaxy will move away from us. So this chart, this spectra of a different celestial object proved that the Hubble's law is correct. So based on how the universe is expanding, today we can estimate that everything was incredibly together about 10 to 15 billion years ago. Now the second evidence of a Big Bang, we get it from the cosmic microwave background radiation. In the year 1964, two radio astronomers named Ernest Penzias and Robert Wilson are working on their radars at Bell's laboratory. During that time, they had detected some unknown signal coming out from all the direction of the space. And when they investigated that signal, they come to know that they had detected the cosmic background signal of a microwave radiation emitted by the universe. It comes from the light energy given off during the Big Bang explosion. During the Big Bang, there are lots of high energy was created. Then the universe expanded and become bigger and colder. And because of this high radiation lost most of its original energy and now has been traveling without hitting anything. So that energy was the cosmic microwave background radiation. Now we are going to detect this cosmic microwave background radiation in this room right now. So for that I have this radio. So you can see this radio. So when I turn this FM radio on, you can hear some static noises there. You can hear. So most of this static noise they are coming from the electronic devices or the atmospheric interference. However, about the tiny fraction, that is about 1% of the static noise, they are coming from the cosmic microwave background radiation, that is 13.8 13.8 billion year old radio wave is captured by that is microwave is captured by this receiver, and you can hear in the form of static noise. So next time when you hear the static noise on your FM radio, then remember it's not just a noise, it's a faint echo from the birth of the universe that is about 13.8 billion year old. So it's a CMB. So the third evidence of a Big Bang, we get it from the abundance of hydrogen and helium in the universe. So we know that universe consists of 74% of hydrogen, 24% of helium, 1% of oxygen, and less than 1% of rest of the element. Scientists wondered why there were more hydrogen and helium than any other heavy element in the universe. The reason is because hydrogen is the simplest element with just one proton, and the next simplest element is the helium with two protons. Hydrogen and the helium are the two simplest elements formed in the greater quantity because the conditions in the early universe favored the formation of these two simple nuclei. Now, in order to make you easy to understand, I have this deck of elements which contain all the elements of this universe from hydrogen to barium. So, if I arrange all these elements according to their atomic weight, then the first two elements I will get is the hydrogen and the helium, because these both are the simplest element in the periodic table. So it means other elements which are heavier than the hydrogen and helium, they added later into this universe. The reason is why, because their weight is more, and like element like the gold, copper, silver and rest of the heavy element, they required the nuclear fission process in order for their formation. And during the initial phase of the universe, their formation is not possible because nuclear fission only possible when there is a star. So this is one of the reasons why we have the abundance of hydrogen and helium in the universe. The fourth evidence of a Big Bang, we get it from the age of the universe. The universe is about 13.8 billion years old. We support the Big Bang theory because none of the object in the universe is older than the 13.8 billion years. So till now we have learned about the evidence of a Big Bang which proved that the Big Bang happened. Now we will begin the story of a Big Bang. About 13.8 billion years ago, the Big Bang happened. Before the Big Bang, there is nothing of space but lots of matter and radiation concentrated at one single infinitely dense point with no volume. Scientists call it the singularity. After the Big Bang, there is a rapid expansion of the universe. That is called the inflation. During the inflation, the expansion of the universe was faster than the speed of light and created everything that you see today. At the time, about 10 to the minus 43 seconds is called the Planck era. In the Planck era, all the fundamental forces of the nature were unified into one. In this extremely hot and dense state, ordinary particle could not form. By the time 10 to the minus 43 seconds after the Big Bang, the universe has cooled enough for the fundamental forces to get separated into four distinct forces. Today we known as the gravity, electromagnetism, strong nuclear force and weak nuclear force. So this separation of four forces allowed the ordinary particle to form, making the beginning of the particle era. At the time 10 to the minus 10 seconds after the Big Bang, there is the beginning of particle era. When the four fundamental forces of the nature were finally distinct, the ordinary particle could form. In the particle era, matter and antimatter were formed. During this era, the particle continuously created and destroyed. When the matter and antimatter they come in contact with each other, they annihilate by releasing the pure energy. But for some unknown reason, there must have been slightly more matter than antimatter. If the number has been exactly the same, the particle would eventually annihilate entirely and there would be only photons in the universe. But luckily, at the end of the particle era, universe ended up with one extra proton for each 1 billion antiproton. This is the reason why we exist today, why everything in the universe exists. Next is the era of nucleosynthesis. The nucleosynthesis began 3 minutes after the Big Bang, when the temperature and density were perfect for the proton to capture a neutron. So one proton combined with the neutron to form a deuterium. After that, deuterium combined with the neutron to form a tritium, and the tritium combined with the proton to form a helium. This happened till 3,80,000 years. After 3,80,000 years, the universe cooled sufficiently that allowed the proton to capture an electron, allowing the light in the universe to freely travel through the space. And we see this light today as a cosmic microwave background radiation. The atoms are now free to bond together to form a simplest element, and this element becomes the building block of the stars and galaxies. About 4 lakh to 400 million years, there is a dark age because there is no nuclear fission, so there is no light in the universe. Because of gravity, the matter are accumulated and got denser and hotter, but not hot enough to start a nuclear fission. At that time, universe was fairly dull. The first star came after about 400 million years When the hotter region fused the hydrogen, the first star was formed by making the universe bright. And the cluster of the stars and matter formed the galaxy, the first galaxy formed by about 1 million years. Then this galaxy collided and merged to form the large galaxy, evolving into the huge supercluster of galaxy which we see today. Our solar system came after 9 billion years. Our sun formed a huge cloud of gas and dust. It was mainly composed of hydrogen and helium and other gases and matter. These gases and dust left over from the initial formed a disk around the sun. Over hundreds of millions of years, planet grew out of this dusky disk and the solar system is formed along with the Earth. For the almost billions of years, Earth was a lifeless place. But around 3.8 billion years ago, after the surface cooled and ocean formed, the first life began from the ocean. And today we are here. So this is the story of you, me and everyone, whatever the thing that existed in the universe. Thank you.